Okay, it's 3 o'clock, so let's get started so we can get closer to the beer at the end of the day. So I'm going to apologize in advance. I literally just finished the last slide while I was out there, and I just barely had time to pee. So preparation is maybe not the best for this one. I marked this talk in the when I submitted it as advanced. So we're going to go straight into the mop. There's no training wheels on this one. We're going to talk about a bunch of details. We're going to talk about some core stuff a little bit. Well, as much as I can get in 20 minutes. So I apologize if it just seems a little bit too complicated. Always ask me later, and I'm happy to explain it in more detail then. So, what is a mop? Who here knows what a mop is? Okay, good. Then I don't really, it's that thing, right? A mop is a meta-object protocol, and where I really learned the most about meta-object protocols is this book. I highly recommend it. I believe I let somebody borrow it, and they let Ingy borrow it, and then I've never seen it again. So I plan to bug him outside and see if I can get it. But anyway, this book has a whole section of it. It's a just giant, 20 pages of Lisp code in which they demonstrate building and bootstrapping a meta-object protocol in a very simple Lisp. And if you can work your way through all the parentheses, it's a very, very educational read and very, very interesting, especially if you like meta-circular things and stuff that makes your head turn inside out. So enough with the book recommendations. A mop, as most of you already know, is an API for classes, roles, slots, and methods. And these are just the names that I've chosen here. In Moose, we call slots attributes, but attributes is a name already taken in Perl, so I decided to call it slots because also fields is already taken and members is already taken. So it was, and it actually fits with the meta-object protocol in Common Lisp calls them slots as well. So yay, I'm following Lisp. I like to call a mop an abstraction of a system of abstractions that is used to build abstractions. This is how I explain it to people when I just want them to go away. Mops throughout the years. This isn't the first one, and I didn't write the first one either. The very first one is that. Okay, that right there is an API to your classes and to your packages, or to your packages, classes, methods, whatever. But it's a little kind of ugly and obtuse. So, also class successor, class method maker, all those things that would auto-generate accessors and other methods for you, those two are kind of a bit of a mop there. It's also an API, again, towards your classes and things like that. In 2005, I wrote Class Mop, which became the base for Moose. Class Mop was a product of about 3 or 4 years of prototyping and probably the 15th version. All the other ones were really bad. I threw them all away. But over the years, I came to regret a number of decisions in Moose and in Class Mop, and one of these days I'll actually give a talk about that. So I started in 2011 to try and rethink this and also to think about how to get it into the core. How to build something that would be appropriate to hoist upon P5P. And for them to maybe maintain if I happen to go away or get hit by a bus or something. So that took many, many iterations, and basically, as far as I'm concerned, I've hit what I feel is the right place on this, and that is the mop module. So we just dropped the whole class part and just kept that. So now we're going to get into the details. First, the design goals. So I had some very specific design goals when I started out trying to think about this in 2011, and those design goals evolved over time. But the design goals that I ended up with and that are behind this module are these. So first things first is low overhead. How many of you have used Moose and looked at your memory usage and gone, all of you, yes. Moose did not really try and have a low overhead at all, and Class Mop, which powered it, also didn't do the same. So this was something I thought, well, that's a challenge. I'd like to figure that one out. Also, Class Mop sort of had complex representations of things. It sort of built a whole layer on top of Perl. I wanted something closer to Perl, simpler representations. Class Mop also managed a lot of state. That's why it took up all that memory. Perl is actually managing the state just fine. I didn't need to duplicate it. So I wanted to figure out a way to basically not have to manage any state within the mop and let the state stay within Perl where it belongs, in the Perl guts, rather. I also wanted meta objects to be immutable. This means that you get them out and you can't change them. If you want to change, you can change the underlying Perl stuff. You can change things through the mop, but the meta objects themselves are static. I wanted to have a more accurate reflection of the state within the Perl interpreter. Class mop and Moose, like I said, they built a layer on top, and that layer on top of Perl essentially duplicated everything. And it wasn't always accurate. It created its own concepts and things like that. So, sorry. Instead, I wanted to try and adapt and reuse existing features in Perl. So I looked and I looked and I looked to find something that would be pure Perl and not even actually involve any code, but I would be able to illustrate or create these concepts through core Perl stuff. And again, avoid introducing new concepts. Sorry, I got that backwards. And again, more suitable for inclusion in core. If I hoist like tons and tons of complex code onto the core, it doesn't help anybody. Yes, maybe we get some cool stuff in the next release, but then the maintenance burden is huge. So I wanted to make sure that the way I approached this kept it simple and with the least amount of code as possible. One of the biggest, one of the trickiest parts and sort of the most mind-bending parts of some of the guts of class mop is the meta circularity. And the hoops that it would jump through in order to enforce this meta circularity. Perl is really lazy. Perl won't do anything until it absolutely has to. And so I decided to try and exploit that so that the meta circular stuff was actually entirely implicit, which means the bootstrap costs nothing, which is nice because the bootstrap and Moose is quite expensive, which I just said before I did that. Like I said, just finished the slides, so sorry, you get what you pay for. I also wanted this to be lazy. If you create a class in Moose, and it has 2 attributes and 3 methods and you're going to end up with 2 attribute objects, a class object, 2 method objects, and probably a bunch of other little shit in there as well. And if you never actually call meta and use it, it's useless. It's just sitting there wasting memory. So I wanted to make sure that this mop was as lazy as possible so it wouldn't do anything until you asked for it. And basically creating the meta objects on demand. So that was the design goals. Oh yes, also I wanted meta objects to be very disposable. That's why they're immutable. So you can't fiddle with them. If you can't change the state, why are you going to keep it around? Throw it away, create another one, and you get the exact same thing again, because again, it's a reflection of the state of the Perl interpreter, not a capturing of the state or a state in and of itself. So one thing, this probably won't make sense to anybody. Nobody's ever really gotten this one because it's just a really weird one. But I drew this picture in 2005 when I was working on the Pugs project. And we were trying to figure out how roles fit into a meta object system. And one of the fun things about a meta object system is you can do weird stuff. Like the class there, that looping thing up there is because class is an instance of class. So it's that bootstrap thing. And so I drew this thinking a role should be a role. Like the concept of role should be illustrated by a role. And a class really does classes and roles do most of the same thing. So a class should do a role. Even though role is also itself an instance of, this is like all over the place and twisty. You have to smoke a lot of weed for it to make sense. And this is not the state to do that in. So when we have Yapsy Denver or something, no. So but I'm very happy to say this is what the new mop does. And I think when I finally figured out how to get this working, it simplified the design a lot. And I hope that the next set of slides will illustrate to you how that design is simplified. If it doesn't, then I'll have to rework this talk. And from now on, these are all the slides that I've just been cramming over the last hour. So John took me to lunch, so if they're bad, blame him. Actually, Vicky and John, so both of them. So, okay, let's see how this pointer stuff works here. Okay, so this is sort of a representation of the parts of the new mop. So most people think of classes as a big part of your object system. Most people think of that as sort of the top, maybe the top of this hierarchy, but it really isn't. Mop role is the important part of this. So mop role gives you access, it's got a version method, which obviously reads the version variable. Also the authority variable, it's got an authority method. If you want to if you're adding roles to your class, well, just like you would put a string inside your is a variable, you put a string inside your does variable. And does is basically how you specify your role relationships. Has, if any of you saw my universal object talk yesterday, has is my proposal for how you store slot information. So has is a hash, it's a package level package variable. The keys are the names of the slots, and the values are subroutine references that serve as initializers for that slot. And then last but not least, all the methods, of course, are stored inside the package stash. So mop role just basically gives you a handle to this package and all those variables in particular. Mop class just does mop role, which means it has all the methods and all the features and everything just automatically included in it. But mop class itself really only cares about inheritance, because really the difference between a role and a class is one can be instantiated and has inheritance, and the other one can't be instantiated and doesn't have inheritance. Beyond that, there's not too much difference. Moose and class mop made a big distinction between the two, and I blurred the distinction a lot more in this, which brings it a lot closer to how Perl 6 actually treats it and thinks about it. In addition, there's also mop slot objects, which essentially are sort of a hash entry or a pair. It's the name and the initializer. The mop code, mop method is just, it's a ref to a ref of the code itself. We have a slot initializer object, and also you can introspect the attributes. So you can see all the attributes for a given method. You can pull them out, and actually it'll parse them out for you and do some fancy little stuff as well. Again, this is much closer to core Perl. Attributes were something we just said, no, we're too cool for that with Moose, and so we didn't even bother supporting that or anything like that. So that was important, I felt, now to get that support in there. Oh yes, and then on the bottom, all these are, these are all subclasses, these meta objects are all subclasses of universal object immutable. So it's all built on top of that. And for those who weren't in the thing, or my talk yesterday, universal object is a base class. It's sort of a universal base class. It also comes with an immutable version of it, which will essentially lock your hashes or arrays or scalars or whatever it is that you're blessing, and it'll make them read-only for you. So it's not quite immutable in the sense of like Java and some of those other languages, which actually aggressively compile things down to much cleaner, quicker code. It's Perl. So we're just locking things and not letting you touch stuff. Okay. So we're going to do a quick review of the API, because this is the best way that I could think of to explain some of the underlying concepts here. So as I said, mop class, it defines three methods. The MRO method, which just literally calls the MRO module. Superclasses, which gives you what the contents of ISA, and set superclasses, which will set the contents of ISA. Remember, this is an immutable class. When you set something in it, you're setting into the underlying package. So again, it's that handle into the internals. And mop class itself is a blessed reference to the stash. So there is I don't create an instance or anything like that. There's no hash ref that stores a bunch of data. Like I said, none of these store any data. So essentially the instance types are usually references to the real stuff in Perl. And actually, I take that back. It's a ref to the ref of the stash, because if you take a ref to the stash and bless it, then you end up blessing the stash, which gets really, really weird. And I don't know if it would really make a mess, but I didn't really want to dig too much deeper. So it's a ref to a ref stash. Mop method has 4 methods here. Halfway, thank you. 4 methods. Mop method is just a reference to your method itself. Again, we do that extra level of indirection to avoid blessing and therefore changing the guts or the actual Perl implementation or the state inside Perl. Body obviously returns the body. Name will query the CV the underlying Perl guts to get the name out of it. It can also tell you the stash that it was originally compiled in, and it can tell you if it was aliased from another stash. So if it's inside your class, but it was aliased from somewhere else, which is what happens during like role composition and stuff. Next is mop slot. It's actually an array reference is the way it's stored with the name and then the initializer, and those are fairly obvious methods in the origin stash, and the was aliased from actually will ask that of the initializer. And this is how we know whether you've inherited slots or whether the slots were defined inside your class. If they were defined inside your class, then your initializers will have a comp stash that points to that particular package. If they were initialized somewhere else or brought in from a role or composed in from somewhere, then that comp stash will refer to a different package. So that's how we know where these things come from. Next is the method attribute, which basically is just a scalar ref to the string that is basically what attributes will give you back. The name, we parse out everything before the parentheses in an attribute, and that'll be the name. And then the args, we parse it in a somewhat primitive way, but you can extend it, so you can pass in your own parsers for it. Mop slot initializer is literally just a blessed code ref, and all that class really does is it makes it easy for you to build some generic initializers, but it just turns into a code ref, which is what it expects to store in there anyway. So it all just works, and it basically has no methods. So those are the little pieces, and like I said, those are again the little pieces. The big piece is the role. So that's where a lot of the meat of this comes. So everybody, hold on to your seats. Here we go. These are all the methods in mop role. It's got a lot of stuff. And I'm going to go through each chunk individually, but just first let me start by showing the stash gives you the handle to the underlying stash, quite obvious. Name refers to the package name, version refers to that version variable, authority refers to the authority variable, and then the rest of the ones will get a little bit more detail. So the roles method will return whatever the contents of does was. Set role, or sorry, that should be set roles. Set roles allows you to set that does variable, and does role will basically do what does is supposed to do in Perl, and I believe, in Moose we do the same. And that'll just basically, if given a role, it will determine whether your class does that role. And again, down on the bottom, so it's our does, and you just put that in there. So it's very naturally Perlish, although a little old school and ugly, but you can always slap sugar on top of these things. Next concept is required methods, or abstract methods if you want. I realized at one point we have that feature already in Perl, in pre-declared subroutines. They will die if you try and call them, just like an abstract method would. These are an important component for roles. When you create a role, a lot of times you can't define all the methods, and you need to leave a few methods undefined that the composing class will then make its own definition for, and those are required methods. So doing this is a lot cleaner. In Moose, we created this whole idea of a required method and all this big stuff, and really it was there the whole time. So the first method there, required methods, will give you the list of all required methods, obviously. Required method, you can ask, do I require this method? Has required method, add, get, and delete do the obvious with the set of required methods, each one taking a name. I should have put the signatures here, sorry. So that's that. Next is slots, and you'll begin to notice a pattern here. The has, add, get, delete pattern I use a lot in there. Slots, you can call all slots and you can get everything that is possibly going to be in your class. That includes anything aliased from another package or defined in your package. And then you can also look at just those that you've aliased and just those that you've defined. That's where slots and alias slots come in, and then you can you go through the other methods if you want to fiddle around with that stuff. What I show down here below, the our has, so this, as I said before, this would be a regular slot because it's defined within that package and we know it's good. The alias slots would happen if you did something like this. So if you're bringing in slots from another class, you would just put them into your has variable. That's how we do inheritance with this, and those would be alias slots at that point. Methods. similar model here. All methods gives you all the methods, the regular methods, the alias methods, and also the it doesn't give you the required methods. Just the regular methods and the alias methods, and again, those other things underneath, doing the same. So this is an example of a regular method because you define it in your class, no problem. But an alias method would be something again, similar to the slot, something coming from another package. So either as a product of role composition or a product of your own fiddling with this low-level mop right here. Okay, I went through that fairly quick, but I wanted to leave a lot of room for questions. So, yeah, questions. How much time do we have, Andrew?
9 minutes.
Okay. Okay, questions. Oh, crap. Come on, people. It's a tricky one. I'm having trouble trying to figure out how to describe this really well and how to explain it really well.
I may have missed it, but is there a way to distinguish between a sub and a method inside of a package?
Nope, because Perl doesn't do that. So again, trying to keep it close to Perl.
Yeah, so just like Moose was built on top of class mop, is there something ready built on top of this, so I don't actually have to understand what you just did?
It's a DIY toolkit, man. No, I have another module called Moxie, which I've been working on. I gave a talk at YAPC Russia this year about it. There's actually a pretty decent recording of that floating around on some .ru server. Use your own discretion. Yeah, the Moxie talk is much more specific, though. The one in YAPC Russia. So the trick about Moxie is that it uses some really, it pushes the boundaries really far. And I was really hoping for signatures to get more stabilized because Moxie depends upon that. And signatures are looking to not be stabilized until like 532, meaning non-experimental until 532. So I'm gonna have to put it on the back burner for a little bit until I can figure some other stuff out. But yes, eventually, yes, there will be something else. The hope, though, is that, yeah, maybe somebody could rewrite some of Moose in this, or perhaps Mo can use this and get a mop and not have to do the upgrade to Moose. I've chatted a bit with Sebastian about modulicious base, things like that. So what I'd really like to do is have a layer that we can a substrate that we can all build upon. So eventually, yes. But okay, somebody else? Is there another hand? Come on, people, we got 9 minutes.
So, can you talk a little bit about your thoughts about getting this into core and what that involves?
Sure. So getting it into core requires. Sorry. He asked about getting this into core. Basically, I have to buy Sawyer a bunch of vegan cupcakes, I think. No, Sawyer is actually more interested in getting this into core than I am right now. I'm cautious, and he's like, well, no, let's just get it in there and let's get started or at least start talking about it. So I do plan at some point in the very near future to at least begin discussing some of this stuff with P5P folks. We had a P5 core hackathon. We have them semi-regularly in Amsterdam. Booking My Company sponsors them. And I've sort of had some discussions with people about this at that point, but it basically just requires convincing people, and then going through discussion. Then you get into naming issues and things like that. So that's sort of why I'm a little bit hesitant, because I want to make sure that I feel strongly enough about these to be able to argue against them.
And
So.
is it going to just be a core module, or is there?
That would be the thought, yes. Unless somebody with far greater C skills than I wants to port it all to XS or to C level stuff. I do have some possible candidates who might do that. I just have to convince them. Yeah, it's a many-step process. It does itself right now depend upon modules that eventually should be written as core elements. So things like devel global destruction, devel overload info, a couple of those modules, which really at some point should just be part of the core. Yeah, it'll take a little while. Henry?
You mentioned that you wrote all this to be lazy. Does that mean that we have lazy instantiation of attributes, or I guess slots now? Is that now all working? Because I know that was an issue with models.
No. When I say lazy, I mean you. Yeah, the mop itself is lazy. So when you create an instance of a mop class, it doesn't create instances of all the methods that are inside of it beforehand.
But when I have a natural slot, but I want to have a default value,
Mhm.
and I want it to calculate that only when I call it. Is that support there yet?
Nope. Well, I have examples of it. It requires tie and stuff like that to do it.
That's what I was waiting on Moxie for. I was ready to start using.
Yeah, sorry, man. So one of the things about Moose was that Moose's attributes encapsulated both the idea of the slot, meaning the value that's stored inside your instance, and all these methods. So accessor methods, or clearer methods, or predicate methods, or other things like that that would be essentially, from Moose's point of view, tightly coupled with the slot itself. I don't do this in the new mop at all. The slots are slots and methods are methods. They don't really mix like that, and so that makes it a little bit trickier because a lazy thing needs a method to initialize it. So I don't know if it really would ever fit inside here, but I mean it can be accomplished in other ways. And again, this is meant for you to build something on top of. Don't use this straight. It's not good that way. So yes.
Conceptually, this seems a lot thinner than class mop
Mhm.
and closer to the core of Perl. Did you find that you could actually implement it with a lot fewer lines?
Yeah.
Are the code count?
Actually, I don't know what the code count. I mean, I can. Let's see if I can show you. Do I have it open? It's yeah. So it's not that much. So like, yeah, that's the entirety of so 81 lines for the attribute. Initializer is only 54 lines. Class is only 53 lines. Method, it's going to get a little bit more, 117. Role is the big one, but still I need my reading glasses, sorry. 798. Slot is quite small, 87. The util package is not that bad. This is where it gets ugly, the internal utilities. This is all the stuff that probably should be written in excess. So this one gets a little long, 400. So 2,000 lines maybe in total. So it's significantly smaller. And yeah, part of this comes from the fact you just didn't have to invent all this new stuff on top of it. So yes, it is slimmer, and the test suite runs a lot faster. Yes.
So what should we do to help?
How can you help? That's a good question. Yeah, so you can use it maybe if you have an introspection or reflection need in your code base and you'd like to introspect to your classes or something like that, try and use it. See what happens, see what breaks. It should be 5.8, it's 5.10 compatible, so it should go back fairly far. And yeah, just let me know how it works. If you are interested in building your own Moose-alike or something like that on top, or you have an entirely better idea of how to do that stuff, try using this as the base for it. Also, you can try convincing people like Sebastian to switch to Mojo Base or Graham Knopp for Moo or something like that. So, okay, cool. We are down to 1 minute, but you were.
We got to get the ball reset to the.
Okay. All right, cool. Then, what's that? MRO, I think, is the reason for that. I don't remember exactly. Yeah, I think it's because oh yes, because I need MRO and there was one or two other things that basically push it to 5.10. If you want 5.8 compat, we can talk. Okay, Dan needs the ballroom, so I guess that's about it. If you have any other questions or whatever, feel free to grab me out there. Okay, thank you very much.